And the project members are Time 7 anak lelaki Pamanati A8449, Amira binti Muhammad Nasir A801363, Nur Aida Syara binti Kamar Zaman A800340, Nur Karina Iwani binti Muhammad Saim A800842, Ainur Syahada binti Abdullah A8448, Sharifah Nur Ashika binti Said Jamal Lail A801373, and lastly Misha Farhana binti Sahran Niza A801350.
Problem statement. So for our group problem statement, a road company wants an engineer to do a road for the 7 cities. In addition, the company provide requirement to the engineer to complete this project, which is spending the lowest cost for the road and explain.
So I want to demonstrate how to use our code. First, I name it as TTDI and add vertex. Okay, the second one, upload here and name as Sunway and add vertex. And the next one, upload it here and name as Clown and I add vertex. So the fourth one, I add here and name it the vertex as City Alam and I add the vertex. Okay, the next one, I upload it here. Okay, then I name the vertex which is Puncak Alam. Then add vertex. Okay, the next one, upload it upload it here and name as the vertex as Shah Alam. Okay, and I add the vertex. And the last one, I upload it here and name the vertex as USG and I add the vertex. Okay, so the first one, I connect verticals between TTDI and Sunway, which is 10 edge weight. Okay, and it's undirected. So the next one, connected verticals, which is Sunway and Clump, which is 13 edge weight and okay. Next, I connected the verticals, which is Clump and City Alam. Okay, the next one, I connect the verticals, which is City Alam and Puncak Alam, which is edge weight 20 and undirected. Next one, I connect the verticals, which is I connect the verticals between Puncak Alam and Klang, that is 17 edge width and it's just undirected. Okay, then I connect the verticals, which is Puncak Alam and between Puncak Alam and Sunway, which is 40 edge width and undirected. So the next one, I connect the verticals, which is Sunway and USG, that is 20 edge width and undirected. Okay, then choose USG between USG and Puncak Alam, that is 15 edge width and undirected. So the next one, I connect verticals, which is Puncak Alam and Shah Alam, which is 10 edge width and undirected. Okay, the next one, it's just between, I connect the verticals, which is between Shah Alam and USG, that is 17 edge width and undirected. And the last one, I connect the verticals, which is USG and TTDI, which is 15 edge width and undirected. So that's all from me.
This is the graph that has been created by all project members. There are 7 vertices represented as the city and are connected by the edges represented as the roads. Firstly, let's take a look at vertices of TTDI, USJ, and Sunway. The vertex of TTDI is connected with the vertex of USJ through the edge of 15 weight, and the vertex of TTDI also connected with the vertex of Sunway through the edge of 10 weight. Meanwhile, the vertices of USJ and Sunway are connected through the edge of 20 weight. Next, let's take a look at the vertices of USJ, Shah Alam, and Puncak Alam. The vertex of Shah Alam is connected with the vertex of USJ through the edge of 17 weight, and the vertex of Shah Alam is also connected with the vertex of Puncak Alam through the edge of 10 weight. Meanwhile, the vertices of USJ and Puncak Alam are connected through the edge of 15 weight. Now, let's take a look at the vertices of Puncak Alam, Sunway, and Klang. The vertex of Klang is connected with the vertex of Sunway through the edge of 13 weight. The vertex of Klang is also connected with the vertex of Puncak Alam through the edge of 17 weight. Meanwhile, the vertex of Puncak Alam and the vertex of Sunway are connected through the edge of 40 weight. Finally, let's take a look at the vertices of Puncak Alam and Setia Alam. The vertex of Setia Alam is connected with the vertex of Puncak Alam through the edge of 20 weight.
The algorithm that we have chosen for our case study is Kriskal's algorithm. So Kriskal's algorithm constructs the minimum spanning tree of a graph by adding edges to the spanning tree one by one. It also adds the next lowest weight edge that will not form a cycle to the minimum spanning tree. So this is our original graph. The numbers near the arcs indicate their weight, and here we can see that none of the arcs are highlighted yet. So moving on to the first step, which we can see that TTDI Sunway and Shah Alam Puncak Alam are both the shortest arcs with the weight of 10. So TTDI Sunway has been randomly chosen, so it is highlighted in green. For the next step, the lowest weight we can observe is Shah Alam Puncak Alam with a weight of 10, and it does not form a cycle. Therefore, it is picked as the second arc. So the remaining vertices left are USJ, Setia Alam, and Klang. On top of that, Sunway Klang are now the shortest arc that does not form a cycle with the length of 13, so it is highlighted as the next arc. So the remaining vertices left now are USJ and Shah Alam. The next shortest arcs are TTDI USJ and USJ Puncak Alam, each of which are with the length of 15. So TTDI USJ is selected and highlighted arbitrarily. There are USJ Sunway that highlighted in red since there is already a path in green between USJ and Sunway, so it will form a cycle from TTDI, USJ and Sunway if it were chosen. The next shortest arc, which is USJ Puncak Alam with the length of 15, is now being highlighted. Many other arcs are highlighted in red now, which is USJ Shah Alam, because it would form a cycle in USJ Shah Alam and Puncak Alam. Besides Sunway Puncak Alam, because it formed a cycle in Sunway Puncak Alam USJ and TTDI. And lastly, Klang Puncak Alam, since it formed a cycle from Klang Puncak Alam USJ TTDI and Sunway. Finally, the process concludes with the highlight of Puncak Alam Setia Alam with the length of 20, and there's no more remaining vertices left. Thus, the minimal spanning tree has been completed with the total weight of 83.